Hello, class. My name is Chris Karras. I'm one of your fellow classmates in the Firefighter Safety and Survival course at Columbia Southern University. I'm going to talk today about water treatment for fire stations and uh, the systems that can be put into existing stations and especially into new stations that could make our water that much better. So a little bit of history is the station that I'm in right now is from the 1950s, and so are the pipes. So is the water delivery system, and so is the ice making system. The ice making system is out in the bay. We're in a brick style building. We got truss roof with a tin top, and our ice machine. These are our apparatus. These are our backup apparatus because our frontline apparatus are broken to the point that no chevrons. Something in our class, right? Well, and this is our ice machine. So we have the aeration industrial air cleaners for each apparatus. There and there. And this right here, the aeration cancel button, which I would say 9 out of 10 people will hit this reset on the way into the station because they don't want to hear it. So our ice is being contaminated by diesel and everything like that, and we're mandated to drink copious amounts of water. Our water is fed through 50-year-old pipes. We have old fixtures from the 80s that deliver the water to the cup. And overall, there is no water at this station that is drinkable because of the rust imperfections. So we have 2 showers, and the showers that we have, one of them has rusted pipes that to the point that it basically puts out red water for the first 30 seconds you run it. And this is the water that we're supposed to decontaminate with after a fire. So the grant money would come towards water conditioners. Real quick, water conditioners are not water softeners. So water softeners take out the select things in water that cause them to be hard water, like calcium and magnesium, things like that, and minorly changes the pH by taking those out. A water conditioner uses a resin filter that the water goes through, and all the impurities stick to the cells of the resin filter, which runs the water through a deionizing salt bath that is next to the filter, and then runs it over when it's done letting the water out through the bottom of the filter, will back flush the resin filter to clean it, and it automatically cleans itself. All you have to do maintenance wise is put salt in the system. So you just have to keep the salt tanks full once every 6 months on an average use. For a fire department, for a firehouse, I would say you probably have to do it once every 3 months, and because it'd be high usage. Initial cost is between $8,000 to $10,000 depending on the labor of putting in the system. We have 11 fire stations, which would come to $111,000. respectively. For the money, what you get is a cleaner station. You get cleaner employees after fires that make us inherently unclean. It'll take more of the impurities out of the water than is safe to drink outright. The water will obtain nutrients and everything from the pipes themselves. Actually, all the different things that are in the pipes now will eventually be cleaned out because of the purity of the water. So any type of calcium, magnesium, anything that you would need in water that you're afraid is going to flush your system is currently exists in the pipes that are here now. You can clean things without soap using the water that is coming out of the hoses for the fire station. You can plumb the system through every pipe in the station. Everything from where we wash our trucks to where we take a shower. And the benefit of this is not only the apparatus won't have water spots, but it'll also cause less soap to be used in the station, which exposes us to less chemicals. So with our ice being made in the bay and everything, we would have to relocate that, which could be done without a grant, let's be honest. But the real money would come into the system itself and the installation. The installation is through the main of the water source that comes into the building and is looped through the filter and then sent back out into the main. So basically it's one connection, and you have to do some digging usually, and it is something that can be stored in the apparatus bay. It is not something that has to be confined or in a room of its own or anything like that. And the benefit of having these systems is that you can drink straight out of the water, the faucet. We're required to fill our coolers and our cups and everything else that we cook with and everything with the water that is 50 years old coming through rusty pipes. And so not only is a system that Maytag or GE can provide a plausible and cost-effective way to reduce the number of toxins that we're exposed to, but it makes the water taste better. It makes the engines easier to clean and the ambulances easier to clean. It removes more because the water is clean. You're using cleaner water, which means that whatever you're cleaning is going to be cleaner. If that makes sense. It should make sense. If it doesn't, I will provide the links and the knowledge, the scholarly knowledge, and we'll go from there. It's a relatively inexpensive way, I believe, to take care of ourselves and take care of our brothers and sisters out there. So it should be a relatively easy grant to write, and we would have $110,000 to retrofit stations and add it to the stations that are currently being built. You can comment below on this YouTube video, and I will be submitting this to my professor, who will hopefully give me an A. Thank you. for your time.